When people first hear AI agent, they often imagine one big answer. In production, that is not what I trust. A real agent is a loop that keeps moving toward a goal, one checked step at a time. The simplest mental model is think, act, observe, improve. The system thinks about the next move, acts through a tool or response, observes what actually happened, then improves the next step from real evidence. That difference matters because polished wording can hide a broken system. An agent can sound brilliant and still choose the wrong tool, misread a failure, or keep looping after the useful work is already done. So in this tutorial, I want to show the loop the way senior engineering teams inspect it, with task state, structured outputs, tool call records, retries, stopping rules, and max step limits. We will anchor the whole lesson on one realistic job. An agent is asked to investigate a failed Kubernetes rollout after a Terraform change and recommend the next safe action, not just produce a clever explanation. That is a good example because it forces the system to touch real constraints. It needs context from the ticket, current logs from the cluster, deployment history, permissions, and a clear boundary between read-only investigation and risky change. It also helps separate the model from the full agent system. The model proposes the next step, but the agent runtime carries the task state, the tool registry, the policy checks, the audit log, and the stop conditions. In other words, the agent is not just text generation with extra confidence. It is a controlled workflow that keeps a small operating state, what I know, what I tried, what happened, what I should do next, and when I must stop. The think phase starts by normalizing the task. Instead of treating the prompt as vague language, the runtime turns it into fields such as goal, scope, environment, time budget, risk level, and the current step counter. Next comes intent extraction. Good agents pull out success criteria and constraints early. For this rollout example, success is not fix everything. Success might be identify the failing service, confirm the error, and prepare a safe recommendation. This is also where structured reasoning helps. I do not mean dumping hidden chain of thought on screen. I mean writing a compact, checkable state object. Assumptions, evidence needed, candidate tools, blocked actions, and the next planned step. Once that structure exists, the agent can produce a small plan instead of improvising endlessly. Step 1, read deployment logs. Step 2, compare the rollout event to the Terraform change. Step 3, decide whether the next action is explanation, retry, or escalation. Now the loop moves into act. The agent has to choose the right tool for the next question. If it needs current rollout evidence, the right move is not memory. It is a logs query, a deployment describe call, or a change history lookup. A safe runtime records that choice as a tool call record. You want the tool name, arguments, environment, permission level, timeout, and a reason this tool was selected, because that record becomes part of the audit trail. Then the system executes. This is the moment where the agent leaves its internal reasoning and touches the outside world. The response might be clean JSON, a shell error, a partial timeout, or a permission denial, and all of those outcomes are materially different. This is also where production guardrails matter. Read-only inspection tools may run automatically, but anything that mutates infrastructure, restarts workloads, or applies Terraform should be gated behind approval, even if the model sounds completely certain. After execution, the observe step asks a harder question than did the tool return something. It asks whether the result actually answered the current subproblem. If not, the loop should not pretend progress just because bytes came back. Good agents also need retry logic, but bounded retry logic. If the log API times out, the runtime might retry twice with backoff or switch to an alternate read path. It should not hammer the same failing call forever and call that persistence. The improved step is where the loop earns its name. New evidence should update the plan. If the logs show image pool failures, the next action changes. The agent should stop chasing Terraform drift and focus on registry access or workload configuration. Every improvement should leave an audit trace. What changed in state? Which assumption was removed? Which new fact was added? Why the next step is different now? That record is what makes the loop explainable to an engineer reviewing the run. Eventually, the loop must stop. Good stopping conditions are simple. The goal is met, the agent is blocked, approval is required, the evidence is insufficient, or the max step budget has been reached. That max step budget is more important than it sounds. Without it, a weak agent can bounce between the same two tools, reformulate the same plan, or chase low-value retries until cost, latency, and operator trust all get worse. The production pattern I trust is straightforward. The model proposes, the runtime validates, tools return evidence, policies control side effects, logs preserve the story, humans approve risky changes. That is how you turn a smart response into a dependable system. So when you evaluate an agent, do not just ask whether the answer reads well. Ask whether the loop thinks clearly, acts with control, observes reality, improves from evidence, and knows when to stop. At Trustscrin, we are building around that problem, and I will show more in future videos.